Thanks for joining us for this session. And in this session, we'll be covering the topic Building an Analytics-Enabled Decentralized Application on AWS. Now, this is a level 300 session where we will go deep with certain technical concepts. There will be a demo as part of this session, and we will wrap the session up with some reference architectures for blockchain workloads. My name is Fabian, and I'm a solutions architect from AWS based in Malaysia. I've been here for 8 years, helping developers build applications on the AWS cloud. My colleague too, a fellow solutions architect, will be joining us later, and he will be covering blockchain analytics. Therefore, without further ado, let's begin with the agenda. And so in this session, we're going to talk about blockchain, what offerings AWS provides to simplify blockchain development, and how to build decentralized applications on AWS. Following that, we will cover some concepts on analytics on AWS, how to analyze blockchain data on AWS, and then we will run a demo to showcase how these concepts look like after being deployed. Finally, we will share some reference architectures to help you envision different implementation possibilities. So now, let's look at some basic concepts in the blockchain that will help to frame the session and understand the services that AWS provides. First and foremost, the blockchain builds trust in the network and eliminates the need for a central authority. It has three main components. First, the distributed ledger technology to ensure changes to chain are immutable and transparent. Next, we have a consensus mechanism to secure the network. And finally, there is also the smart contracts execution environment that enables the blockchain to be programmable. Together, this component enables secure multi-party transactions without a centralized authority. And so let's start off with the distributed ledger. This is a database that stores the current state and the historical states of the data. And every change to the ledger is stored in a journal and is cryptographically verifiable. You can inspect the transactions and make sure that between one change and the next, no fraudulent data has been inserted. Another important aspect of this ledger is that it's distributed. It's copied on all the nodes in the network so that if any one node loses its data, it's not the end of the world. The other nodes can replicate that data to that node. So this duplication of data is by design, and it helps to increase the robustness and the failover support of the network. Another important aspect of a blockchain network is the consensus mechanism. The consensus mechanism enables decentralized systems to work together and determine what constitutes a valid transaction, protecting the network against malicious actors. There are different types of consensus algorithms, and you may have heard of things like proof of stake, proof of work, and sometimes hear about proof of authority. And different algorithms are needed for different types of networks, such as private versus public blockchains. With private blockchains, you already have a greater degree of trust between the participating parties. So you may not need quite as much protection against malicious attacks, which could enable you to support higher transactions. On the other hand, the public blockchain time to complete a transaction may be longer, as there are more parties involved in validating the transaction. And therefore, the consensus algorithm you choose becomes crucial in this circumstance. And the other crucial component of the blockchain is a smart contract. It is simply a program that runs on the Ethereum blockchain, similar to a stored procedure running on a database. The smart contract is a collection of code and data that resides at a specific address on the Ethereum blockchain. Smart contracts are not controlled by a user. Instead, they are deployed to the network and run as program. This means agreements between parties are codified, deployed, and then executed when called upon. User accounts interacts with a smart contract by submitting transactions that execute a function defined on the smart contract. Smart contracts cannot be deleted nor updated, and the interactions with them are irreversible. And that's it. What we got here is a three-layer cake that illustrates these three concepts. At the base, you got the distributed ledger, and then the consensus mechanism, And finally, the smart contracts. Together, it enables decentralization while keeping the database secure, transparent, immutable, reliable, and programmable. But we're still in early days when it comes to blockchain networks, and it's quite difficult to set up a blockchain. It is difficult to stitch together a lot of this infrastructure and pretty challenging to get it running. It is also difficult to scale when you're adding more members to the network, growing your ledger, and growing your network. It's also not easy to keep it up and running and to maintain it. Security updates, governance, and other challenges can be difficult. And all of the time and effort and expense it takes to manage these different things can result in high costs and slows your blockchain development time. And so, at AWS, we strive to improve the user experience of our customers. And we built what we call Amazon Managed Blockchain, which is a fully managed service that makes it easy to create and manage scalable blockchain networks using popular open source frameworks. The available blockchain protocols that we support today are Hyperledger Fabric and Ethereum. First of all, the network is fully managed, and you can set the service up in minutes, what used to take hours or days to wait for your network to deploy. Because it's based on popular open source projects, with that comes along with strong community support. We've added some important features around the governance of the network, including convenience features that help you add or remove members to your network as you need to. Also, we've made tight integration in our blockchain service with various underlying data and control plane technologies at AWS. So by integrating tightly with our data and control planes, you can achieve greater reliability, durability, scalability. Like all of our services, this managed blockchain service is pay as you go. You only pay for the resources you're using. You can turn them off at any time, and it's also tightly integrated with all the other AWS services. And you can easily create a solution that involves several services. So, let's talk about some of the characteristics of the public blockchain and what benefits it provides. First of all, participants can be anonymous. You can open a blockchain application to a wider public audience. Also, the public blockchain doesn't have any access control mechanism that anyone can use. In a public blockchain, anyone can mint NFTs. You can create tokens, deploy smart contracts. With many public blockchain applications, no one needs to get permission prior to participating in these applications. And participation only requires owning a non-custodial wallet. These decentralized applications can run autonomously without depending on any private infrastructure. And these public blockchains, among many other use cases, are currently enabling the development of what we call decentralized finance, or DeFi, which is a really exciting space that's growing rapidly. So at AWS, in our Amazon Managed Blockchain service, we offer some options for both private and public networks. Specifically, in our recent release of Ethereum support, we offer dedicated Geth nodes that are managed by AWS. And you can provision these nodes in minutes on the mainnet, Ropsten, and Rinkeby networks. And you have much faster sync than a typical Geth node that you would normally start up, because we are using reference nodes and synchronizing the state of their blockchain regularly, so that when you launch a new blockchain node, you're only catching up to the latest changes. We also support higher availability through quick failover of faulty nodes and auto-scaling of node storages, so you don't have to worry about your disk space. The Amazon Managed Blockchain service enables applications to interact with the Ethereum blockchain. Now that we have covered the basics, let's explore the building blocks of a decentralized application, also known as a Dapp. But before jumping into a Dapp, immediately, I'd like to draw parallels between a Dapp and the standard web application. Taking a step back, let's have a look at what a technical architecture of a simple standard web application looks like. To simplify, we'll use the three-tier web application as a reference. The three-tier web app consists of the presentation tier, application tier, and your database tier. On the presentation tier, this is the application front end built on HTML, CSS, and JavaScript. On the application tier, also known to be the application's backend, this section consists of the business logic running on PHP, Python, .NET, Go, so on and so forth. And finally, the database tier, this is the database engine of choice based on your technical and business requirements. And you may be running an open source database such as MySQL or PostgreSQL or commercial grade database such as SQL Server or Oracle. And when you put it side by side with a Dapp, you'll see that the technical architecture is similar with differences in implementation and technology utilized. The web browser and presentation tier remains the same. However, at the application tier, the business logic is implemented into a smart contract. At the database tier, the blockchain serves as the database, a ledger that stores information of transactions that were validated. The smart contract is deployed directly on the blockchain, and therefore, you can think of the smart contract similar to a stored procedure running on a database. The smart contract is executed upon invocation, and its execution behavior is dictated by the program business logic and the values passed to it across its binary interface. And now that we are across building blocks of the Dapp, let's look at the different AWS services you can use to build your Dapp on AWS. We will unpack the Dapp into three separate tiers: presentation, application, and database. On the presentation tier, there is Amazon CloudFront for content delivery, AWS WAF for application protection and security, AWS Shield for DDoS protection, and Amazon S3 to store static content. On the database tier, there is Amazon Managed Blockchain that gives you read and write access to the Ethereum chain. The service synchronizes the state of the blockchain and facilitates a new blocks to the blockchain. And that's it. For a simple Dapp, that is what you would usually need. However, while typically these AWS services are sufficient to power a Dapp, in some use cases, it may not be appropriate to store the data in the public blockchain due to several reasons. The first reason would be the need to comply to personal data laws. Second reason would be managing costs, where larger payloads may lead to longer processing times and higher gas fees. There are other reasons to consider, and therefore this creates the need to store some data off-chain. In this off-chain use case, you can use serverless services such as AWS Lambda, Amazon API Gateway, or Amazon DynamoDB to meet your business objectives. These services are the typical building blocks used to develop serverless applications on AWS. And so, equipped with the knowledge what AWS services to use, let's take a look at a decentralized application AWS reference architecture. To put things into perspective, say, this is an NFT marketplace decentralized application, and in this NFT marketplace, you're managing your customers' cryptocurrency wallets as a custodial wallet. Now, similar to every other web application, the NFT marketplace will have a front end, an application layer for business logic processing, and a database. Putting on the lens of AWS services on your left, which is the front end, you have edge services such as AWS S3, CloudFront that serves as the entry point to customers. What CloudFront does is deliver content at low latency with near real-time response. You also have AWS WAF and Shield with CloudFront to protect your dApps from being compromised or being overwhelmed from cyber attacks. In the middle, which is the business logic processing layer, you have Amazon API Gateway and AWS Lambda that receives the JSON RPC request, signs the request with SIG-v4 and forwards that to the AWS Managed Blockchain. To store off-chain data such as customers' personal information, you can use Amazon DynamoDB, and you could also include AWS Cognito for off-chain user authentication. On your right, you have the AWS Managed Ethereum Dapp node to relay blockchain transactions or query the state of the blockchain. When you put all these AWS services together, this is what a typical Dapp looks like. Now that we understand how to deploy a Dapp on AWS, let's bring this to the real world. Imagine you have a product built on the decentralized application. You're getting great demand and all things are going great. And then your product team realizes that they have no great ways of running analysis against the gold mine of data that's buried in the blockchain. A question that may come would be, how would you analyze your data in the blockchain? Another question that may arise would be, how do you associate your data to non-blockchain data such as personal information? And the answer to that would be, let's make the data available in the data lake. And so keep in mind that the blockchain is just another data source and that you can extract your application's data out of it for further analysis or enable more downstream use cases. And that's me giving you an introduction to blockchain and decentralized applications. I would like to invite my fellow colleague too to talk about blockchain analytics on AWS.
Thank you, Fabian, for giving us a solid foundation on how the blockchain works and how to build decentralized applications on AWS. But the journey doesn't stop there. There is a crucial component we have not touched yet, and that is the data collected by the application. My name is Tu, and I am a solutions architect based in Thailand, mostly working with assisting customers in the SMB sector with many years of experience developing full-stack applications. Now, let's talk about the fact that businesses are always looking for more value from their data. And this data enables them to gain visibility across their business, make better decisions, enable ML capabilities, and many more reasons. What customers need to be aware of is data is growing exponentially, up to petabytes and exabytes. In some cases, it's coming from new sources such as IoT devices and digital channels, or in our particular case, the blockchain. This increasingly diverse data needs to be securely accessed and analyzed by a number of applications and personas. Traditional on-premise data analytic approaches cannot handle these data volumes and complexity. This is because they don't scale well enough and are too expensive. And so, how do you capture the events that occur in the blockchain? In Ethereum, whenever a smart contracts function is executed, it can be programmed to emit a smart contract event. These events can be captured through subscription. Alternatively, you can fetch past events through pre-built APIs, for example, get past events. On this slide, have a look at the left. You'd see that the new item function is programmed to emit mint events whenever a new item is created. To listen to events, you can have an AWS Lambda function polling to fetch and process the events, enabling more downstream use cases such as analytics or app messaging. Once the events can be extracted, you can turn these events into insights with AWS Analytics services such as Kinesis, Athena, and QuickSight. These services would ingest your data in near real time. You can perform interactive querying to explore the data, process the data, and then visualize it for business reporting or for business intelligence purposes. To expound further what these services are, firstly, Athena is an interactive query service that makes it easy to analyze data directly in S3 using standard SQL. It is serverless, so there is no infrastructure to manage. With Athena, there is no need for complex ETL to prepare your data for analysis, and most results are delivered within seconds. This makes it easy for anyone with SQL skills to quickly analyze large-scale datasets in S3. You pay only for the queries that you actually run, and you can easily see how much each query costs. Secondly, Amazon QuickSight, our business analytics service. QuickSight makes it easy for employees within an organization to build visualizations, perform ad hoc analyses, and get business insights from their data, anytime, on any device. If you want to quickly search and analyze large amounts of log data to monitor the health of your production systems and troubleshoot performance, you can use Amazon OpenSearch service, successor to the Amazon Elasticsearch service. Amazon OpenSearch service makes it easy for you to perform interactive log analytics, real-time application monitoring, website search, and more. OpenSearch is an open-source distributed search and analytics suite derived from Elasticsearch. Amazon OpenSearch service provides open-source OpenSearch APIs and integrations with Logstash, also known as the ELK stack, and is tightly integrated with other AWS services such as Amazon Kinesis Firehose, AWS IoT, and Amazon CloudWatch Logs, just to name a few. You pay only what you use. There is no upfront cost or usage requirement. For when you want to do real-time processing of streaming data, you can use Amazon Kinesis or Amazon Managed Kafka service. If you have complex queries against structured data and you want super fast query results, you want a data warehouse like Amazon Redshift. We'll get into more detail on these in just a bit. Now, in this demo, we are looking at a decentralized application with a smart contract deployed to the Ethereum Ropsten testnet through the Amazon Managed Blockchain service. We also have a AWS Lambda function that's listening for contract events and sending them to a Kinesis data stream for further processing, with Amazon DynamoDB used for event state management. So these event streams will be used for downstream analytics, as well as visualizations with services such as Amazon S3, Amazon Athena, and Amazon QuickSight. In this demo, I'll be demonstrating the end-to-end process of minting an NFT, listing it onto the market, capturing the events that are emitted, then using them for analysis. Here we have an example NFT marketplace that we put together, featuring one of the NFTs minted on our smart contract, with the majority of the information coming directly from said smart contract. Now let's try minting a new NFT. On this screen, we can define what image we are going to use. For example, we'll be using this image of Bangkok. Let's name it Bangkok and give it a basic description. The royalty percentage you see here determines how much the original owner of the NFT receives each time this NFT is resold. We'll leave it at 5%. Now we can create the NFT. In the backend, the image is being uploaded to S3 and the information is being written to the blockchain. This process will take a while, so let's move forward to when the NFT has been minted. Now, our NFT has been minted on the chain and anyone can look at the details and confirm the owner. Now, if we wanted to sell the NFT, we'll list it as available for purchase. We just set the price we wish to sell for and list it. Again, this process also takes a while, so we'll be viewing the results of the listing later on. Since all of the information that we write, the actions we take are all stored on the public blockchain, anyone can view them if they know where to look. We'll be using the tool Etherscan to achieve this. Here, we have the page representing our smart contract. We can view our code and the events that have occurred on this contract. Under normal circumstances, the details of the events and the raw code of the smart contract is not visible. However, we have published it for the demonstration purposes. Normally, a contract will only emit events for transactions. However, by customizing the code in the contract, we can emit events whenever we want. So by adopting an approach similar to the user tracking on a website, we are emitting events for when anyone mints an NFT, lists it on the marketplace, when it is sold, and when it is delisted from the marketplace. Example here being minting an NFT. Next, let's see the events that have occurred on this contract. Here we now see our events, the NFT we minted, and the list event. By clicking on the transaction and going to logs, we can see the details of the event that was emitted, which is as we defined in our contract code. Now we have all our data on the blockchain. How do we hook this up to our usual data analytics pipeline? As we talked about earlier, we have a Lambda function scooping up events that are being emitted from our contract. Then Lambda passes the information to Kinesis Firehose to collate and store in Amazon S3. In order to query this data, we will be using Amazon Athena. Using Athena, we can query our data using regular SQL syntax. Developers who are already familiar should be able to transition with no problem whatsoever. First, let's view all the events. Here you can see the mint and list events that we made right at the top. Now what if we have a more complicated situation? So maybe we want to see how many NFTs were minted within a certain time period. we can simply run a familiar SQL query and voila, we have all our mint events. What if we wanted to cross our information with additional information such as user data? Well, Athena can help us with that too. We can perform a cross-table join in SQL like so. And now we have the data with context, who the user is, and where they come from. So now we have saved our data onto the blockchain, emitted the events, captured them into S3, and can now query them in SQL. Lastly, let's build a dashboard. For this project, we are using QuickSight. QuickSight allows us to directly interface with data from Athena. Here, we can create graphs and other visuals to illustrate our data points in a more concise manner. We've created a few example graphs here by merging data from the blockchain with user data which is saved normally from a website. By using QuickSight, we can easily illustrate monthly comparisons on our sales numbers and users and minted NFTs. A good example of how this data visualization could help your business is the event summary. By filtering what events we want, we can see the current trend in user actions, such as how here we can see that the number of NFTs being minted is not increasing, but the number being listed and purchased is growing, which could indicate a growth in reselling. We could leverage these insights to determine future actions to take. Now that we have showed you how you can analyze your blockchain data, we'd like to show you architectures for different blockchain workloads based on their respective use cases. In this reference architecture, we are looking at how might we enable decentralized applications with machine learning capabilities. Similar to the demo we have shown before, this is a decentralized application with a smart contract deployed to the Ethereum network through the Amazon Managed Blockchain Service. In the center, we have Amazon Kinesis data streams, fanning out its output to two destinations. One destination for analytics purposes, another destination for anomaly detection, leveraging Amazon Kinesis data analytics. Specifically for anomaly detection, the random cut forest algorithm is utilized. It detects anomalies which are then passed to AWS Lambda for downstream processing. Whenever an anomaly is detected, the operator will be informed via Amazon Simple Notification Service. Moving along, in this reference architecture, we are looking at how might we enable decentralized applications with search capabilities. As we are familiar with by now, whenever a new block related to a smart contract is added to the blockchain, an event will be emitted. The event will be fanned out to separate destinations via the Amazon Event Bridge service. Amazon Event Bridge invokes a Amazon Lambda function as a target, have the event processed and stored in the Amazon OpenSearch service for search use cases. The data stored in Amazon OpenSearch can then be visualized through Kibana. All the architectures demonstrated can be mixed and matched depending on what your requirements are. Now, if you are looking beyond blockchain and would like to further your cloud journey, you can take a look at our training and certification resources to get digital classroom training. And so, with all that said, thank you for attending this session. This was Tu and Fabian from AWS. And we really appreciate your feedback so that we can better understand the topics and services you would like to know more about. So please do take the time to fill out our survey and let us know what you think.